All right, so our question today is how to solve a linear systems of equations, the word problem. The word problem we're looking at is the Carlo and Anita mailbox and toy problem. And the current problem that I have is Carlo and Anita make mailboxes and toys in their craft shop near Lincoln. Each mailbox requires 3 hours work from Carlo and 3 hours from Anita. Each toy requires 2 hours work from Carlo and 3 hours from Anita. Carlo cannot work more than 18 hours per week, and Anita cannot work more than 24 hours per week. If each mailbox sells for $8 and each toy sells for $17, how many of each should be made to maximize their revenue? So the first thing we're going to need to do is read the problem, reread the problem, get a general idea of what it is we're asked to find. If you'll read the problem and reread the problem, it tells us about Anita and Carlo and how many hours they can work. It also asks us to find how many mailboxes and toys they should make to maximize their revenue. So let's start there. The thing that we're looking for is number of mailboxes and number of toys. So that's at the top of our list. We're looking for mailboxes and toys. So the easiest way to work these problems is to make a table. So X is information about mailboxes, Y is going to be information about toys, and then I'm going to put any totals I have at the top of my chart. And then along the side of my chart, I'm going to put any factors that I know about these mailboxes and these toys. And what I'm given in this problem is the number of hours that Carlo can work and the number of hours that Anita can work. So there I go, Carlo and Anita, those are my constraints, the number of hours that they can work. And we also know that we're given some information about profit. So let's fill in the chart here. What do I know about the number of hours that Carlo can work on the mailboxes? I know that each mailbox requires 3 hours of work from Carlo and 3 hours from Anita. So Anita in mailboxes is also going to get a 3. And then I know each toy requires 2 hours from Carlo and 3 hours from Anita. So Anita and toys gets 3 hours. I also know that Carlo cannot work more than 18 hours. So he has less than or equal to 18 hours that he can work. And Anita cannot work more than 24. So I'm filling in my table. Next, I need to figure out what I know about profit and mailboxes and profit and toys. So each mailbox sells for $8 and each toy sells for $17. And I don't have a total. This is the thing that I'm trying to maximize. So my linear programming problem looks like this. Maximize, and you can call this Z or P or whatever it is that you like, 8x plus 17y. So I'm getting those two numbers from right here in my chart. And this is subject to the following constraints, that for Carlo, he can work 3 hours on my mailboxes and my 2 hours on toys, but he can't work more than 18 hours total. Anita can work 3 hours on the mailboxes and 3 hours per toy, but she cannot work more than 24 hours. Even though it's not stated in the problem, I also know that X needs to be greater than or equal to 0. That is, I'm not going to make a negative number of mailboxes, and I'm also not going to make a negative number of toys. So these are the constraints that I have to work with to maximize this problem. So those are called my constraints. So what we'll do next is turn each one of these constraints into an equation and graph. So the first one I'm going to graph will be 3x plus 2y equals 18. For these types of problems, it's easiest to graph this line using x and y intercepts. So to find your 2 points to be able to graph the line, go ahead and use your x and y intercepts. So the first point we're going to find on this line is going to be our y-intercept, or where x equals 0. So let x be equal to 0, and we're going to have the equation 2y equals 18. So solve for y, and I get y equals 9. So 1 point on this graph is going to be at 0, 9, or 1 point for this line. The next time I'm going to let y be equal to 0, I'm going to find the x-intercept. So let y be equal to 0. It'll cancel out this term, and I get 3x equals 18. Solve for x. So x is equal to 6. My x-intercept is at 6, 0 for this first line. Do the same thing with the second line. 3x plus 3y equals 24. I'm going to graph this line using x and y intercepts. So let x be equal to 0 and y be equal to 0. And find 2 points so you can graph the second line. When x is equal to 0, I'm just left with 3y equals 24. Solve for y, so y equals 8. 1 point on this line is at 0, 8. The second time I'm going to let y be equal to 0. So if I let y be equal to 0, I'm just left with 3x equals 24. Solve for x, and x is equal to 8. So this has an x-intercept at 8, 0. So what we'll do next is we'll actually graph both of those lines. And I know my x and y intercepts don't go past 10, so I made a graph just from 10 to 10. So my first line had the point 0, 9. Go and mark that. And had an x-intercept at 6, 0. And I'm going to attach my lines here. Okay, so this was actually the equation 3x plus 2y is less than or equal to 18. So that means all of the answers to this line are either all over here or all above the line. I need to decide which one is which. So if I pick a test point like 0, 0 and test it in my inequality, I get 0 is less than or equal to 18, which is true. So I would shade the area underneath this line. Okay, so this is the region that makes the first inequality true. My second inequality that I made from the problem was 3x plus 3y is less than or equal to 24, and it had an x-intercept at 0, or a y-intercept at 0, 8, and an x-intercept at 8, 0. So I'm going to mark those 2 points on my graph. Connect those two lines. So the second one is 3x plus 3y is less than or equal to 24. Same thing. It's again an inequality, so I need to decide where is the area that makes this inequality true. Is it above the line or below the line? And if I pick a test point like 0, 0, I see that this inequality would be true. So plug in 0 for x, 0 for y, and that says all the ordered pairs below this line make the inequality true. Now we did have two more inequalities, x is greater than 0 and y is greater than 0, but we actually took care of those already because if you'll notice I only drew the first quadrant. So in the first quadrant, all of our x values are greater than 0 and all of our y values are greater than 0. Okay, so where is the place that all four of these inequalities, x greater than 0, y greater than 0, 3x plus 2y is less than or equal to 18, and 3x plus 3y is less than or equal to 24. Where is the space that they all have in common? And that's right here where I have all of this overlap. So this is the solution region for this linear programming problem, or this system of inequalities. There's a rule that says the maximum or minimum values is found at one of the corner points. So look at the corner points for our shaded region. And it looks something like this, and so mine are a little off, so I'm going to have to figure out why exactly or where exactly some of these points are. Some are going to be easy for us to find. So one of the corner points is at 0, 0, And this is part of the reason I tell you to graph these lines using the X and Y intercepts because they're usually part of your corner points. So we already know that this corner point is at 6, 0. We found that from graphing our first line. This corner point is where our second line meets the y-axis, and that is at 0, 8. And so what's left is for us to find this corner point that's made up of 3x plus 2y equals 18 and 3x plus 3y equals 24. So we need to find what point these two things have in common so we can find that intersecting point. You can do this in a couple of ways. You can look at your graph. Although I don't trust my graph, it looks like it's at around 1, 7. My graph's probably not to scale, so I'm not going to trust it. You can put this in your graphing calculator, so you could solve each one of these for y, put this in your graphing calculator, and use second calculate and intersect. You can use a matrix and find where these two lines overlap, or you can use substitution or elimination. If I'm going to do this by hand, I'm just going to use elimination. Elimination is when you add two equations together and you cancel out one of the variables. So notice if I add these two equations together, I would get 6x, 5y, and something else. But I'm not going to do that because I wouldn't get one of my variables to cancel out, so I'm going to have to adjust my equation a little bit. I'm going to multiply this bottom equation by -1. So I'm going to solve the system of equations 3x plus 2y equals 18 and -3x minus 3y equals -24. Okay, so now add these two equations together. I have 3x minus 3x, and that gives me 0. My x's have canceled out. 2y minus 3y, that gives me a -y, and 18 minus or plus a -24 gives me -6. Solve for y equals 6. Take this and plug it back in. 3x plus 2 times 6 equals 18. You can plug it back into either one of those equations. I get 3x plus 12 equals 18. Subtract 12. 3x equals 6. X is equal to 2. All right, so just looking at my graph, I thought that x was going to be equal to 1, but it looks like my x is going to be equal to 2. Now take this 2, plug it back into either one of those equations above. I'm going to do that down here. So x equals 2, plug it back in. 3 times 2, oh, never mind. I already knew y was equal to 6. What am I thinking? Okay, so this corner point is at 2, 6. Our next step is to make a table. So all of our corner points, we had corner points at 0, 0, 0, 8, 6, 0, and 2, 6. And the thing we're trying to maximize is 8x plus 17y equals z or p or whatever it is that you wanted to call this. So we're going to plug those corner points in. Eight times 0 plus 17 times 8. 8 times 6 plus 17 times 0, and 8 times 2 plus 17 times 6. All right, and what we're trying to do is look for the maximum profit. So use your calculator and figure out what each one of these is equal to. When x and y are both equal to 0, we get a profit of 0. When we make 0 mailboxes and 8 toys, we have a profit of $136. When we make 6 mailboxes and 0 toys, we make $48. When we have 2 mailboxes and 6 toys, we make $118. So our maximum profit is $136 when we make 0 mailboxes and 8 toys.